At the expected value of a random variable. And the expectation is just the mean value of the random variable. The mean value is just another way of saying the average. So for a random variable, we're just wondering, what do we expect on average? And this is called the expected value. And it is written as the expected value of the random variable capital X. And the formula for expected value is the sum of all the observed values times their probabilities. So E of X is the expected value. That's the average of the random variable. X is the observed value. And P of X is the probability. And capital X is the random variable. So this looks complicated, but we'll see it's not so bad when we look at some examples. So for example, if you're tossing a fair coin, and we're going to say that the random variable is the number of heads that we get. And we want to find out the expected value for that random variable. So we can do this with a probability tree. So the first branches of the tree are what we get when we toss the coin the first time. We can either get heads or tails. And the second branch of the tree represents when we toss the coin the second time. So we can either get heads or tails the second toss. And each of those has a 50-50 chance of happening. So we'll mark the probabilities on the tree. And then to find the total probability for each event, we just multiply. So the chance that we get 2 heads in a row is 1/2 times the half, which is a 1/4. Chance that we get heads and then tails is also a 1/4. Tails and then heads, 1/2 times a half, and tails and then tails is 1/2 times a half. If we add all those things together, we get 1 because that's all the possibilities, 100%. So let's make a table, just like we did last class, of the observed value versus the probability of that random variable happening. Okay, so the random variable is the number of heads that we get. And the number of heads that we could get is either 2 heads, and that's the first branch of the tree, or we could get just 1 head out of 2 tosses, or out of 2 tosses we get 0 heads. So the chance that we get 2 heads is 1 out of 4. Now there's 2 ways that we could get 1 head. Either we get the head first, or we get the head second. So we're going to add up both of those probabilities. 1/4 plus 1/4 is a half. And there's only one way that we could get no heads, if we toss tails and then tails. Tails and then tails has a probability of 1/4. That's 0 heads. Okay, so this is review from last class. Now to find the expected value for the number of heads that we get is the sum of all the observed values times their respective probabilities. So what that means is we're just going to take the number 1, or well, actually we can start with 0, times the probability that we get 0 heads, plus the number 1 times the probability that we get 1 head plus the number 2 times the probability that we get 2 heads. And we're just going to keep doing this until we finish with the whole table. So the easy way of doing that would just be to take 0 times 1/4. You're going to add that with 1 times 1/2. You're going to add that with 2 times 1/4. So the total is 0 and 1/2 and 2/4, which is 1. So the expected value is 1. Now what does that mean if we translate that into normal English? Since x is the number of heads, the expected value is the average number of heads we get when we toss a coin. How many times? Twice. So if we toss a coin 2 times, we expect that one of them will be heads. Because on average, we're probably going to get 1 tail and 1 head if we throw the coin twice. So that really makes sense. Now for example B, random variable x can only take on the values 1, 2, and 3. So what that means is that the possible values are just 1, 2, and 3, and that represents all the possibilities. So if we find all those probabilities, they should add up to 100%, because they told us that it can only take the values 1, 2, and 3. Now given that the value 3 is twice as likely as 1 and 2, and 1 and 2 are the same likelihood, can we find out the probabilities? So I don't know what the probability is. I'm going to put a variable for those. I know that 1 and 2 have the same chance. So I'm just going to give them the same letter. Maybe A. I don't know what A is. I just know that they are both the same probability. And then value 3 is 2 times as likely as 1 and 2. So I don't know what the probability is, so I'm just going to call it 2A. Now because I know that I have the whole space, this is a probability distribution, all the probabilities should add up to 1, because that's 100%. So 4A equals 1, so A is 1/4. So that means if I want to write out this table with the probabilities, I have 1/4 chance for 1, 1/4 chance for 2, and 2 times 1/4 is 1/2. 1/2 plus 1/4 plus 1/4 is 1. And getting a 3 is twice as likely as getting a 1 or a 2. Now to find the expectation, I just have to add up all the x's times the p of x's. So I'm just going to take the first x times the first p of x, and then this summation notation means that I'm just going to add that to the next x times p of x, and add that to the next x times p of x. So I get 1/4, 2/4, and 3/2. So that's 1/4, 2/4, and 6/4, which altogether is 9/4. So what does that really mean? That means on average, I expect to get about 2.25 in this experiment. Now normally, if the probabilities were all even, then I should see like 1/3 chance of getting 1, 1/3 chance of getting 2, 1/3 chance of getting 3. And then my expected value would just be the average, 2. But because I've got more probability on the 3, my average moves up a little bit more, closer to 3. So instead of having an average right exactly at 2, my average is just a little bit bigger than 2, 2.25. Now for question C, the random variable x has a probability distribution given by this formula here. And x has these 4 possibilities. So I'm going to write a table of my x versus p of x equals x. So my x can be 1, 2, 3, or 4. And then it represents all the possibilities. Now my p of x is the little number x divided by k. So that would be 1 over k, 2 over k, 3 over k, and 4 over k. I don't know what k is, but I do know that these are all the possibilities. So that means my whole space should add up to 1, because it represents 100% of all the possibilities. You're quite often going to use the fact that all the probabilities add up to 1. Now luckily I have a common denominator, so I can just add the tops. 1 plus 2 plus 3 plus 4 is 10. So 10 divided by something is 1. That something must be the number 10. 10 divided by 10 is 1. So k is 10. Now I can fill in all my proper probabilities. 1/10, 2/10, 3/10, and 4/10 chance. So to find the expected value, I add up my observed values times their probabilities. So I take 1 times 1/10, 2 times 2/10, 3 times 3/10, and 4 times 4/10. Okay, so just looking at this, if all the probabilities were the same, then I would expect to get about 2.5. I'd expect that my average would be 2.5. But because there's so much more chance of getting a 4, my average is going to move closer to 4. So I'm guessing my average will be closer to 3, or maybe a bit bigger than 3, something like that. So now I'll check. This is 1/10, 4/10, 9/10, and 16. 16 plus 9 is 25, plus 4 is 29, plus 1 is 30. 30 over 10 is the number 3. So on average, I'm going to get about a 3 in this experiment. So for practice, take a look at your textbook, page 525, numbers 2, 5 to 7, and 10.